So this is Newton's method, and when we say this, we mean it's Newton's method of approximating roots. Approximating roots. Or basically figuring out when is f of x equal to 0. So we're trying to solve when is a function equal to 0. So we have to come up with approximating things because sometimes equations get so complicated that we can't solve them. Flat out, cannot solve them. So what we do is he came up with this cool trick. Let's say we have some kind of function like this. Okay, we'll just kind of sketch it on. I'm trying to find this root right here. That's my goal. So what we do is we pick an initial guess. Probably call that x0. That's my initial guess. And it's just kind of my guess. It might be kind of close. It might not be too close. And so we pick a guess. Then what we will do is we'll find the tangent line. So we find the tangent line at that point. And the tangent line will actually cross a little bit closer than will be closer than our first guess. So now we're actually guessing at x1. We'll put it on our function. Then we do the same thing again. So that point is a little bit closer, but still not as close as 1. So that was x1. So then we draw the tangent line at that point and see where it crosses. And look, it actually crosses right at the root. So my second guess, or that was my first guess, second, third, I guess if you want to call it that, actually led me to the root. So again, what are we trying to do? We're trying to figure out where it crosses the x-axis. And what is our method? We pick a point at, we call it x0, that's the x value. Then we know that's not going to be exactly right, so we draw the tangent line. Wherever that tangent line crosses, that x coordinate is our x1. Then we try again. Wherever that tangent line crosses, that's our next guess. So each of these are guesses. So you come up here to, and that's your next guess. And then, oh wait, no, that's right here. Then you do the next tangent line. So now this is my guess. Go to the function, draw its tangent line, and I think we're about there. Sorry, it's hard to see with my drawing abilities here. So what does that actually look like? So we're finding tangent lines and seeing, and then whatever that x value is where it crosses, that's our new guess. So first of all, how do you find a tangent line? Well, you might remember from your algebra classes that you have point slope form. So it's y minus, okay, so again, we're doing point slope form. Point slope form for line is if you know a specific point on the line, you do y minus the point that you know equals your slope times x minus the point that you happen to know. Now those ones are going to get confusing. I'm just going to put little like stars since we're going to have lots of 0, 1, 2, 3s. So this is your normal point slope form. Let's see what we can rearrange here. So let's change this to y equals y star plus your slope times x minus the x value that you have. So that's our general equation for a tangent line. This is your y value. The y value that we know for any of these points okay. Sorry, so this y value, we're trying to find the tangent line at any of our guesses. So the star is for like whichever guess that I'm looking at, okay? So y at that star value would just be your function at whatever your x guess is. Now, how do you find your slope though? So let's come over here so we can find our slope. Well, luckily we have a way to find the slope of any equation at any point. It's called our derivative. So to find our slope will just be equal to the derivative of f of x at that specific guess. So we'll find the derivative at our guess point times x minus whatever our guess is. So this is the equation of the tangent line. But we're not done yet. This is, again, only the equation of our tangent line. So we found our slopes, we found the equation of our tangent lines. But what we're actually trying to do is find this root. So remember, each time I drew my tangent line, let's see if I can start again. Better drawing. If I do concave up, I can see better. So here's my x guess. Here's one of my guesses. And what I do is I find the tangent line, and remember my next guess is where the tangent line crosses the x-axis. So we need to see where does the tangent line cross the x-axis, because that is my next guess. So what we're going to do, how do you figure out where a line crosses the x-axis? You set it equal to 0 and solve for x. So you set your line equal to 0 and solve for x. Okay, this is my equation, my line up here. So let's set that equal to 0. So 0 equals f of, remember this is x star for just whatever my guess is, plus my derivative at my guess times x minus my guess. Let's see, we're trying to solve for x. So I'm going to start by moving f of x over, f at my guess equals the derivative at my guess times x minus my guess. So we would want to divide both sides. So we have negative f at x star over f prime at x star equals x minus x star. And move that x over. So we have x star plus f evaluated at x star over f prime of x star equals x. This is my next guess. Okay, so again, we start with the guess, we draw the equation of the tangent line. That's what we found here. Where your tangent line crosses the x-axis, which we find by setting equal to 0 and solving, that is your next guess. And every time you keep coming up, and then you'll come back up and you'll do a new tangent line, see where it crosses, and do it over and over, and eventually you'll get to where it actually does cross. This is a very effective way to figure out what the roots are, where our equations are set equal to 0. So that is how you derive it. That's the general idea. So now what is our official formula? So Newton's method says you start with an initial guess, which they call x0. Now this can be you looked at a graph and you guessed. This can be you kind of made a shot in the dark. Maybe they gave you an interval. They said, well, we think it's between like 1 and 3. So you just kind of pick the middle and go with 2. It's just some kind of initial guess. Usually graphing is a great way to pick an initial guess. And then your next guess is, we'll write xn plus 1 for our next guess is equal to xn plus the function evaluated at xn over f prime at xn. So they do n's and n plus 1s. I did the star, but that's how you find your next guess. What you need to do is just keep doing that until your answers are all agreeing to 4 or 5 decimal places, and then you can stop. So a good example of this is, let's find where f of x equals cosine of x I don't think I want to do one quite that complicated for this. Let's do where f of x equals x squared minus 2x plus 6 crosses the x-axis. So I'd start by graphing it. I like to go to Wolfram Alpha. Okay, so I realized that won't actually cross. So x squared minus 2x minus 6, where it crosses the x-axis, let's just do the positive result. So there are going to be 2 roots here. So looks like my initial guess is that it's somewhere between like 3 and 4. So coming here, I'll say my initial guess will be x0 equals 4. So that's my first guess. So let's try this formula. First though, I will need to find the equation of the derivative. Let's make this simpler. Okay, so just in general, the derivative is going to be x squared minus 2x minus 6. Sorry, that's my function. The derivative is 2x minus 2. Now let's put all of this into my formula and maybe we can simplify something. So it'll be my guess plus the actual function is x squared minus 2x minus 6 over 2x minus 2. I don't think this is actually going to simplify, so this will actually be xn and xn and xn. Okay, so what we have to do is just plug this in. So we have x0, so x1 is going to be equal to my first guess, which was 4, plus 4 squared minus 2 times 4 minus 6 over 2 times 4 minus 2. And I better go get my calculator. Oh no, I'm so sorry. Sorry, it is. I am tired. This is a minus. That was a minus. That should be a minus. I was not getting accurate results. This should be a minus. This should be a minus. And that should be a minus. Let's see if that gives me better results. So when I put a 4 in, I get 3.6666. So my first guess was 4. My second guess is 3.6666. Now let's try a second guess. So I'm going to do the exact same thing, but I put in the 3.66 wherever I see x. So 3.6666 minus 3.6666 squared minus 2 times 3.6666. You'll get some long decimals here, so you kind of have to get used to that. In fact, your teacher probably wants you to do more than 4 decimal places. My calculator is just only doing 4, and this is just a video to help you, so you probably have to do like 6 or 9 decimal places or something. 2 times 3.6666 minus 2. And so that will give me 0.6666. That gives me 3.6458. So that is my next guess. So now I'm going to do the same thing, but I'm going to plug in 3.6458. minus, and do the exact same thing and see what that gives me. That gives me 3.6457. Notice how I'm starting to change this. I went from 4 to 3.666, 3.6458, 3.6457. So you can tell we're getting really close. Let's try again. So let's put in 3.6457 and do the same thing. And when I put that in, I just get 3.6457. So I'm not even changing anymore. Now, again, if you're going out to 6 or 9 decimal places, you're going to get even better results. Now, we could have gone back to Wolfram Alpha just to kind of double check this. And we could set this equal to 0. And see what it tells us the solution is. Now, if you've ever wondered, how do they come up with these solutions? They use things just like this. So if it's not something they can do easily, they're just using a calculator. So they have this 3.6458. They must have rounded. If you're doing it out to, again, those 6 to 7 decimal places, you're going to be more accurate than what I did here. So there are a lot of functions that we cannot actually solve algebraically to figure out where their roots are. So we have to use Newton's method. Again, what is it? You find the tangent line and you make a guess and find the tangent line at that guess. Your next guess will be closer. So then you do another tangent line at that part, see where the tangent line crosses, and that's your next guess. But basically, when it comes down to it, you just have this formula. You start with the first guess, and then this is always what your next guess is. You take your guess minus the function at that guess divided by the derivative at that guess. And you just keep going until your guesses start agreeing with each other.